Welcome to another deep dive. So whether you are, prepping for a major technical meeting, trying to keep up with just the endless avalanche of tech news, or you are just an insanely curious learner, you are absolutely in the right place.
Glad to be here, and yeah, we've got a fascinating one today.
We really do. And today, we are looking directly at you, the listener, and an experience you have almost certainly had. So imagine you finally buy that charming, slightly rundown house you've been saving for, right?
Oh, the classic fixer-upper trap.
Exactly. You start renovating, and there is always that one room, the one where you confidently peel back the 1980s wallpaper and suddenly realize the electrical wiring is from, like, 1950.
Yeah.
The plumbing is held together by sheer willpower and duct tape, and the floor joists don't seem to connect to anything at all.
It becomes the room you quietly back out of, lock the door, and desperately pretend doesn't exist just so you can sleep at night.
Right. If you work in technology or, frankly, any modern business that uses software, you know that every single company has the digital equivalent of that room.
Absolutely. The legacy code base.
Yes, the legacy code base. It is massive. It is messy. The original architects left, 5 years ago.
Yeah.
And dealing with it is incredibly frustrating.
Yeah.
But right now, there is an immense level of hype sweeping through boardrooms.
Oh, massive hype.
Because everyone thinks they have finally found the ultimate magic wand to fix that room overnight. And that is generative AI.
On paper, the promise is incredibly seductive. You just point a large language model at the mess and let it clean things up.
Right.
But the source material we are unpacking today paints a very different, much more alarming reality. Waving that generative AI magic wand blindly over your software architecture is currently acting as a silent architectural death sentence.
Wow. A death sentence. And we are pulling our insights today from a deeply fascinating text called The Refactoring Illusion, Why Blind AI Code Upgrades Accelerate Systemic Architecture Rot.
It's a great paper.
It really is. So our mission for this deep dive isn't just to, marvel at AI writing code. We want to uncover the mechanical reasons why throwing generative AI at your technical debt often causes catastrophic system collapse.
And we aren't just bringing you doom and gloom here.
No. Definitely not. We are going to walk through a specific, structured framework the source outlines called the monolith protocol that actually works to modernize code safely.
Yeah, the desperation driving this trend is palpable, and we really have to understand the human element before we look at the tech itself.
Okay, let's unpack this. What's the human element?
Well, our source highlights a staggering metric driving this whole phenomenon. Engineering teams are currently burning up to 33% of their operational velocity just managing code base rot.
Wait, 33%?
Yep, 1/3.
Let's put that in perspective for a second. A third of a highly paid, highly skilled engineering department's time is just vaporized. They aren't building the new mobile app feature. They aren't improving the checkout experience. They're literally just acting as digital janitors trying to keep old, brittle systems from crashing.
Exactly. And engineering leadership looks at that massive sinkhole of capital, and then they look at these, flashy demos of large language models instantly writing Python scripts.
The temptation is overwhelming.
It is. So they issue what the text identifies as the ultimate high-risk command. They tell their teams, take our massive 20-year-old monolithic repository, feed it into the AI, and have it rewrite everything into clean, modern microservices.
I can completely see myself making that call. If I have an AI that knows every programming language ever written, it seems logical that it could just map out the whole system and fix it.
Right, it feels intuitive.
Yeah, does it just ingest the code and build a giant 3D mental map of the whole application before it starts typing?
See, that is the illusion. And it leads us directly to the core friction point the source calls locality bias. Standard LLMs do not build a mental map of your software.
They don't.
Not at all. They are constrained by strict context window limitations. They can only hold a certain number of tokens or chunks of text in their working memory at any given second.
Okay.
Fundamentally, they are just engines of probabilistic text prediction. They do not truly compile or understand software architecture.
So what are they actually doing then?
They simply predict what clean code ought to look like based on the billions of lines of open source data they were trained on.
Ah, so it's essentially playing the world's most advanced game of autocomplete. It's looking at the immediate lines in front of it and saying, usually a modern developer would write this next.
Yes, it is entirely localized, and that locality bias is incredibly dangerous for enterprise software.
Why is that so dangerous?
Because true software architecture is a web of macrosystemic dependencies. A database schema over here dictates how a user profile renders way over there.
Right, it's all connected.
Exactly, but because the AI is blind to the global picture, it executes a localized optimization. It zeroes in on a single messy function on page 4 of your codebase, and it rewrites it to look absolutely pristine.
But I'm guessing that function on page 4 was secretly tied to a critical payment validation process all the way over on page 400.
You nailed it. And by cosmetically cleaning up page 4, the AI just introduced a silent, catastrophic breaking change to page 400.
Oh man, it's like a blindfolded house flipper renovating a skyscraper.
That's a great way to look at it.
They might paint the fourth floor lobby beautifully, but they just accidentally removed a load-bearing pillar on the 40th floor.
Precisely. Now, you might wonder why our existing safety nets don't catch this.
Yeah, if the compiler passes, how can the AI be so dangerously wrong?
Well, the compiler, the software tool that checks if your code is structurally valid before it runs, might actually pass the AI's new code. The compiler says, yes, the syntax is correct. This is valid code.
Okay, so looks fine to the machine.
Right. But when you deploy it to your live production environment and real customers actually start using it, the entire system buckles under the load.
It makes me think about spell checking a recipe. You can run a spell checker over a recipe that calls for 2 cups of bleach.
Oh, wow.
Yeah, and the computer verifies you spelled bleach perfectly. The syntax is flawless.
But the semantics are deadly.
Right. The computer has no idea that you shouldn't bake a cake with bleach. The actual real-world meaning and consequence of the instructions are completely lost.
That is a phenomenal analogy. The compiler only checks syntax, the grammar of the programming language. It does not check the business logic.
Which is unique to the company.
Exactly. The semantics are unique to your specific company. The AI creates a structurally valid load-bearing pillar that happens to be made of styrofoam instead of steel.
And the compiler sees a pillar and approves it.
Yep. The system crashes when the weight of reality actually hits it.
Wow. So if we leave the AI to its own devices with this locality bias, the source outlines a sequence of disastrous failures that will unfold. Let's walk through the anatomy of how an unconstrained AI destroys a system.
Sure. It usually starts with what the text calls the dependency deletion.
Dependency deletion.
Okay. If I'm an AI scanning through a 10-year-old legacy system and I see a block of code that looks redundant or relies on an ancient utility library, how does my probabilistic brain process that?
Well, I mean, your training data is filled with clean, elegant, modern repositories from GitHub, right?
Yep.
So your statistical bias leans heavily toward modern patterns.
Exactly. So when you encounter an ugly, convoluted, seemingly obsolete block of logic, your probabilistic response is to aggressively prune it. You just delete the dead code to streamline the file.
Which sounds great in theory, except that in the real world of legacy business, that ugly block of code is almost never actually dead.
No, it rarely is.
It's usually a hyper-specific workaround. I can imagine a scenario where the legacy payment processing system secretly depends on a weird timing glitch in that exact obsolete library just to calculate international shipping taxes correctly.
We see that all the time in enterprise systems. The AI deletes the messy code to achieve syntactic elegance, and the immediate consequence is that the company silently stops calculating taxes on European orders.
Oh, no.
Yeah. Revenue just leaks out of the system and nobody knows why because the code looks cleaner than ever.
Okay, let's say the AI doesn't delete it. Let's say it decides it's going to be helpful and upgrade the messy code.
Which leads to the second failure.
Right. The source warns about this second major failure called the paradigm clashing. Now, here's where it gets really interesting. I would think upgrading the logic is what we actually want the AI to do. But this introduces a philosophical problem with how code is written, doesn't it?
It really does, because programming languages aren't just different vocabularies. They often represent entirely different paradigms, different fundamental philosophies for organizing logic and data.
Right.
A massive portion of legacy enterprise code is object-oriented. That paradigm groups data and the behaviors that modify that data together into things called objects.
Like a noun that can perform actions. A user object holds the user's email and also has a built-in method to update that email.
Yes, perfectly stated. But modern software engineering, especially in highly scalable cloud environments, strongly prefers functional programming.
Okay, how is that different?
Functional programming avoids objects modifying themselves. Instead, it relies on stateless mathematical functions that take data in, transform it, and pass it out without changing the original data.
So our eager AI, trained on the newest functional programming trends, looks at a 20-year-old object-oriented monolith.
And it tries to force modern functional principles onto it. It tries to weave stateless functions into a system that expects stateful objects.
That sounds like a disaster.
It is. The result is a Frankenstein hybrid architecture. You end up with objects that behave like functions and functions that bizarrely try to maintain state. It is functionally incoherent.
It's like taking a wooden horse-drawn carriage and bolting a supersonic jet engine onto the back of it.
That's exactly what it is.
The AI is standing there proudly saying, "Jet engines are faster, I upgraded you." But the carriage is rattling itself to splinters. How is a human engineering team supposed to fix a hybrid system they didn't even write?
They cannot. It becomes completely unmaintainable. And to make matters worse, the AI obscures this disaster through the third failure, which is the documentation void.
Okay, the documentation board.
You might hope that the AI would at least leave detailed notes explaining its strange Frankenstein architecture so the human developers could decipher it.
But it's an LLM. It's a people pleaser. If it doesn't know the answer, it's just going to hallucinate one, isn't it?
Totally. It generates documentation that sounds incredibly authoritative, highly plausible, and uses all the correct formatting.
But it's completely wrong.
Completely. The descriptions are entirely disconnected from the bizarre structural changes it actually made in the code. Your engineering team is handed a shiny new code base and an immaculate set of instructions, and literally neither of them reflect reality.
Wow. The overarching theme of these failures is crystal clear then. True modernization is not syntax conversion. You can't just make old code read like modern code and call it a day.
No, you really can't.
The source argues that true modernization is the surgical preservation of business logic inside a scalable structure.
Right. Treating AI as an autonomous developer is a trap. If we want the speed of AI without the systemic collapse, we have to pivot our entire approach.
Which brings us to the solution the source presents. Since treating AI as an autonomous developer leads to these three catastrophic failures, how do we bound the AI? Enter the monolith protocol.
Yes, the monolith protocol. The core mindset shift here is that we stop treating the AI like an independent senior engineer. We have to treat it like a highly bounded refactoring engine.
So we don't let it make unilateral design decisions.
Never. You must define the legacy behaviors, draw the architectural boundaries, and set the performance targets before the AI is ever allowed to process a single line of code.
Okay, so it's a structural blueprint.
Exactly. The protocol operates in a strict sequence of constraints. The very first layer of this blueprint is establishing the behavioral immutability ledger.
Behavioral immutability ledger. This implies we are mapping out the exact data transformations that the system must preserve at all costs, right?
Yes.
But, okay, there's a detail in the text here I really struggled with. It states that the team must painstakingly document the legacy bug compatibility requirements.
Ah, yes.
Wait, we actually want the AI to keep the old bugs. Why wouldn't we want it to fix everything while we're under the hood?
It is deeply counterintuitive, I know, but it touches on the reality of how long-term enterprise software actually functions. In a system that has been running for a decade, today's bug is tomorrow's critical feature.
Wait, really? How does that work?
Consider a legacy system that has a slight rounding error in how it calculates inventory depreciation. It's technically wrong. But for 10 years, the downstream reporting databases, the corporate accounting software, and the predictive financial models have all been built to expect and adjust for that exact slightly wrong number.
Oh, wow, I see. The downstream systems have evolved around the bug.
Exactly.
If the AI silently fixes the rounding error so the math is suddenly perfect, the accounting software will reject the data, or worse, process it incorrectly.
Yes, you trigger a massive data integrity failure across the entire company. Those quirks are load-bearing business rules.
That makes total sense.
The behavioral immutability ledger forces the AI to document those exact quirks so they survive the transition intact.
Okay, so we've mapped out all the quirks and logic we need to protect. The next step the text outlines is the structural extraction map. This seems to be where we solve the AI's locality bias.
Right.
Since the AI can't see the whole house, we are literally drawing lines on the floor and saying, you are only allowed to work inside this specific box.
Precisely. You are explicitly decoupling the monolith. You give the AI a rigid map, like, here is the exact data payload coming into this boundary, and here's the exact structure of the data payload that must exit this boundary.
And it has to stay within those lines.
The AI is not allowed to change the shape of those inputs or outputs.
Once those walls are up, we finally move to the execution phase, what the source calls the protocol refactoring output. This is where we actually let the AI write code, right?
Finally, yes.
But because it's locked inside the boundaries we defined and forced to adhere to the immutability ledger, it channels all of its generative power into optimizing within those constraints.
That's the beauty of it.
It generates the pristine code with maximum type safety and the memory management features of whatever modern environment you are moving to.
It does the syntax modernization beautifully, but only because the structural thinking was already done for it.
Right.
However, the protocol does not operate on trust. The final phase is mandatory, the compilation verification matrix.
The verification matrix,
You do not just ask the AI to generate the new application code. You command it to build an exhaustive, automated unit testing suite alongside it.
like JUnit or Mockito, which the source mentions, for listeners who aren't in the weeds of Java every day, JUnit is essentially a framework that runs thousands of tiny automated checks against your code.
Yep.
And Mockito lets you simulate or mock other parts of this system so you could test one piece in isolation.
And under the monolith protocol, those automated tests are engineered to assert that the inputs and outputs of the newly generated code match the legacy behavior down to the exact bit value.
It's the ultimate lie detector test.
Yeah.
You aren't just taking the compiler's word that the syntax is fine.
No, you can't.
You are forcing the AI to scientifically prove, mathematically, that it didn't break the business logic.
It completely removes human trust from the workflow and replaces it with cryptographic level verification of the system semantics.
Okay, I want to make sure we ground all of this architectural theory in reality so the listener doesn't get lost in the weeds. The source provides a brilliant, concrete case study that perfectly illustrates the difference between unguided AI and the monolith protocol.
The 2012 Spaghetti Code Showdown.
Let's walk through it. What's the setup?
So the source dissects a messy snippet of Java code originally written in 2012 for processing user accounts. On a surface level, it's a simple method,
Okay.
but it contains a classic piece of technical debt. Tightly wound inside a loop that saves data to the database, there is a hard-coded business rule. It's a VIP tier threshold evaluating if a user spends over $1,000.
So the deciding logic, who gets to be a VIP, and the persistence logic saving the data to the hard drive are completely tangled together.
Exactly. It's structural spaghetti.
First, the source walks through what happens when you feed this file to a standard, unconstrained AI refactoring tool.
Right, the standard approach.
The AI spits out an updated file and proudly declares the code is modernized. It gives it a cosmetic fix. It gives all the variables very readable names. It implements a modern Java enum to handle the VIP tiers.
Which looks nice.
An enum is just a neat way to define a fixed list of constants rather than using random text strings, so it looks incredibly polished. But did it actually fix anything?
If you look past the cosmetic polish, did the AI actually change the architecture? It did not. The deciding logic and the database saving logic are still tightly coupled inside the exact same monolithic method.
So what does this all mean? It basically slapped a fresh coat of paint over a crumbling foundation. It didn't actually modernize the architecture. Why is the standard AI so obsessed with just making things look pretty?
Because unconstrained AI prioritizes syntax over structure. It failed to decouple the logic because decoupling requires an understanding of how the system needs to scale in the future.
Which it doesn't have.
Right. The AI doesn't know that your marketing team might want to evaluate VIP tiers independently of saving to the database next year. It just knows how to make the current structure look prettier.
Which is the perfect segue into what happens when they run that exact same 2012 spaghetti code through the monolith protocol instead. The output here is completely different.
No, night and day.
It isn't just a cosmetic touch-up. It is a professional standard, a fundamentally different class of software engineering.
The protocol forces a structural shift. It physically isolates the tier evaluation logic away from the database persistence layer.
Right.
It extracts that VIP calculation into its own pure function.
A pure function meaning it takes an input, returns an output, and has absolutely zero side effects. It doesn't secretly try to update a database or change a global variable in the background.
Yeah.
It is completely predictable.
Exactly.
They wrap this pure function into a new module called the Account Tier Modernization Service.
By isolating it into a pure function, it is now fundamentally decoupled. It is ready for a modern cloud-native serverless deployment.
Which means the company can run that specific calculation in the cloud on demand, scaling it up to millions of requests instantly without having to boot up an entire dedicated server just to check a VIP status.
Yep.
Now, that is a proper studs-out remediation of the architecture,
And crucially, the protocol delivers on the verification matrix we talked about.
the testing phase.
The automated test suite it generates doesn't just check if the code runs. It writes a highly specific test, checking a user balance of $1,000.01 to verify that the exact legacy behavior is preserved.
Down to the penny.
Yes, it verifies the exact boundary threshold from the legacy code is flawlessly preserved in the new serverless architecture.
It fundamentally changes how the system operates and scales under pressure, rather than just changing how the code reads on a monitor. The contrast is staggering.
It is the stark difference between aesthetic, clutter, and precision engineering.
Well, as we wrap up this deep dive, there is an overarching takeaway here for you, the listener. Whether you're leading a development team, managing a digital product, or just trying to navigate the relentless wave of AI tools entering your workspace,
It's an important lesson.
the source sums up the danger perfectly. Velocity without structural guardrails is technical bankruptcy.
That's the quote of the day. If you hand your critical repositories over to unconstrained AI simply because you are desperate to move faster, you are making a fatal trade.
You're just trading visible, ugly technical debt for an invisible, sprawling web of architectural failures.
Exactly. The debt does not disappear. It just hides behind clean syntax until it brings down your production environment under load.
You have to stop defensive rewriting.
Right.
Don't just let the AI polish the spaghetti. You have to command your system architecture by locking down your boundaries first.
Use the principles of the monolith protocol.
Yes. Force the AI to isolate, map, and mathematically verify the business logic before it is allowed to modernize the syntax.
It is the only way to guarantee that your modernization efforts yield an elite, production-grade infrastructure, rather than just a beautifully formatted maze of broken software.
It really paints a vivid picture of where human skills are headed. Before you send an automated demolition crew into that old, dusty house with the 1950s wiring, a human being has to meticulously map every single pipe and structural pillar.
They absolutely have to.
Which leaves us with a truly provocative thought to mull over.
Yeah.
If an AI's natural probabilistic tendency is to hallucinate generic, clean code that actively destroys the unique, quirky business logic of a company,
Yeah.
will the most valuable human software engineers of the future not be coders at all? Will they instead be code archaeologists?
Oh, that's an interesting term.
Specialists whose sole job is to excavate, map, and fiercely protect the bizarre human quirks of a legacy business before the AI is allowed to even touch the keyboard.
That is a fascinating future to picture.
Think about what that shift means for your own skill set and where the true value lies in the years to come. Thanks for joining us on this deep dive. We'll see you next time.